Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the southernmost moon. Today is Griffith Observatory's 90th birthday, and the waning gibbous moon is doing something it hasn't done for 18 years. It is rising and setting as far north and as far south as it has ever seen. And this happens every month over a period of about 2 years in a cycle that lasts 18.61 years. It's called the Major Lunar Standstill, and we are now about 3/4 of the way through the standstill season. I'm Dr. Ed Krupp, Director of Griffith Observatory, and this cheering and unusual astronomical event is part of a 2024-2025 campaign to follow the greatest monthly excursions of the moon. It is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks, and, of course, the law of gravity, which is responsible for the moon's behavior. The sun celebrated Griffith Observatory's 90th birthday earlier tonight when it set at 7:48 p.m. Pacific Daylight Time. Observatory cameras are now targeting this view of the southeast horizon from below the observatory's south promenade and east terrace. And in a short time from now, the waning gibbous moon, 2 days past full, will rise on this line just about as far to the south as we ever see it. The moon will appear over the distant mountain ridge at about 10:14 p.m. Pacific Daylight Time, and the Griffith Observatory live stream broadcast team is prepared to catch that moonlight. The broadcast team includes Matthew Burlando, production engineer, Vanessa Alarcon, observatory astronomical observer, digital communications coordinator Pixie Iwata, video production coordinator Ella Ritz, observatory carpenter Grant Armstrong, stage manager Michael Noble, and me. We first broadcast the southernmost moonrise in June and July of last year, and since then we've also transmitted the southernmost moon set and the northernmost moonrise live to the entire world. The moon hasn't been rising and setting this far south and north since 2006. Its orbit is now tilted at the greatest angle outside the path of the sun. Those white disks represent the moon on its path, and the other circle is the sun's path. On the ground, this means over the rest of the year, we'll see the most northern and southern moonrises and moonsets the moon ever reaches, and those points are outside the sun's annual limits, as we see here. Well, here again is our major standstill moonwatch view. The southernmost moon will appear on the line of lights that extends across the pavement. Now, the greatest excursions of moonset are marked with lines on Griffith Observatory's lower west terrace, along with lines for the solstice and equinox sunsets, and for moonsets when the monthly excursion is least, at minor standstill. The most northern and southern moonsets last happened in 2006 when the observatory was still under construction for renovation and expansion. The stone for the line had not been placed into the pavement at that time, and this is, in fact, the major standstill northern moonset on January 28, 2006. Well, between now and December, the moon will each month continue to rise and set as far north and as far south as it ever can. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for almost 2 years. The sun does something similar, but it does it over the course of a year. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it, and 6 months later, in December, it rises at its southernmost limit on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and sunset then seem to stand still, and the time when this happens is called a solstice. which means sun still. Well, the Griffith Observatory cameras are still targeting the southeast horizon, where the southernmost moon will soon rise. Now, if we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon on the near side of this view, and from there they climb up the sky to their greatest height and then head back down to the western half of the horizon on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the north celestial pole, a spot that is directly above the Earth's north pole. Now, if that were all that moves, the sky would be simple, but other objects like the sun, the moon, and planets also all move around the sky on their own paths at different rates. Here we imagine the sky as a sphere with the Earth at its center, and we can see half of the sky overhead, but the other half is hidden by the Earth beneath our feet. The sun's path through the entire sky is called the ecliptic, and it's just a reflection of the Earth's orbital motion around the sun. Sun takes about 365 days, a year, to complete its circuit, and the tilt of the sun's path shifts the sunrise and sunset from north to south and back again in a year. Each month, the moon circles the Earth in 27 days. The tilt of the moon's orbit guarantees the moonrise will also migrate from north to south and back to north again in that time. So the moon does, in about a month, what the sun does in a year. It moves from north to south and back again. But the moon does something else. The moon's monthly limits gradually change, and over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits, and then back outside of the sun's limits again. The moonset lines on the lower west terrace of Griffith Observatory make this obvious. The gray lines for the northern moon's inner and outer limits flank the gold summer solstice sunset line that points to the northwest. The gray lines for the moon's southern inner and outer limits flank the gold winter solstice sunset line that points to the southwest. When the moonrises and moonsets reach these limits, the limits just don't seem to change much from month to month. These periods are called the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. Well, we are now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits, and the extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside the solstice points and will be at the minor standstill. And then the monthly limits will, again, gradually increase. And in 2042, we'll have the next major standstill. So mark it on your calendar. Now, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun, as we can see here. The moon and the Earth are not exactly in a line. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. And then these edge-on views of the Earth, the sun, and the moon show how the moon's orbit flips from greater angle to a smaller angle and back to a greater angle again, all with respect to the sun. And although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. Okay, we're still several steps ahead of the Major Standstill southern moon, which will show up soon. Now, despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, as we see here, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the Station Stones rectangle at Stonehenge. The rectangle enclosed the main circle of stones in the center of this plan and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill Southern Moonrise and Major Standstill Northern Moonset. So here is the view to Major Standstill Southern Moonrise, and here is the Stonehenge Station's view to Major Standstill Northern Moonset. Hawkins also proposed sightlines between certain gaps in pairs of archways formed by the large sarsen stones erected perhaps 500 years later. This pair of openings in one of the group of sarsen stones accommodates the Major Standstill Northern Moonset. That's where it would show up. Stonehenge was not the first prehistoric monument assigned a major lunar standstill alignment, however. In 1908, British naval officer Boyle Somerville published a Major Standstill Northern Moonrise line for the Callanish stones in Scotland's Outer Hebrides. In the 1980s, Gerald and Margaret Ponting instead favored a long alignment more or less to the south, to the low southern moon. Here, in fact, is that transiting moon hugging the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified Major Standstill southern alignments in the recumbent stone rings in northeast Scotland. The big recumbent stone on the moon's line operates like a stage, which runs across as the southern moon rises and moves in the southern sky. This, in fact, is the view to the southwest from the center of the Castle Fraser stone circle in northeast Scotland. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old Major Standstill Northern Moonrise alignment with the axis, this axis here, of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. And Stephen Patricia reconstructs here Newark's Major Standstill Northern Moonrise, looking along that line and watching the moon come up along it. An ancestral Pueblo great house, about 1,000 years old at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the Major Standstill Northern Moonrise framed by the distinctive rock pillars in the background here. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon in October 2023. And Dr. Amanda Bosch of Lowell Observatory caught the December 2023 full moon at Chimney Rock. The Griffith Observatory remote live stream internet broadcast team captured and transmitted worldwide the Major Standstill Northern Moonrise at Chimney Rock again last September and October. And those broadcasts are available on the Griffith Observatory website. At this time, the broadcast team is scheduled to return to Chimney Rock for another broadcast in September. Deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and through the rest of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are now about to witness in real time the Major Standstill southern moonrise from the southeast corner of Griffith Observatory along a moonrise line headed southeast over Elysian Park, Santiago Peak, and on to Palomar Mountain. The moon may be standing still, but Griffith Observatory never stops moving. Thank you for joining this Griffith Observatory broadcast of Griffith Observatory's 90th anniversary Major Standstill Southern Moonrise. This broadcast has been brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks.